Hi, everyone. Thanks for joining our session. We have John Mainzer of the HDF Group. He'll be our host today. And John, you can just go ahead and get started whenever you're ready.
Sorry, having a little bit of trouble with audio here. So, yeah, I'm sort of a substitute. Very happy to take questions. My area of specialty is the lower levels of the library, so I'll be able to help best there. And if we run out of questions and if there's interest, I have a presentation that I gave at EuroHug on some recent developments, most particularly with a re-implementation of SWMR that I can present and use up the remaining time for. So, any questions before we get started?
John, I would love to ask a bunch of questions, but I'm going to refrain at the moment. I'll wait till later.
Okay. I'm sure you have all sorts of questions, Steve.
Yes, I do. I have many questions, John.
All right. Well, the silence is somewhat deafening. So if I can figure out how to share screen, I will bring up the slides for that presentation. And okay, can everybody see this set of slides?
Yep.
Okay.
Yes.
So this was a presentation talking about some developments in the lower levels of the HDF5 library, most particularly concerning new VFDs. The VFD section is pretty straightforward, and we'll go through that quickly. The new implementation of SWMR may be of greater interest. Please feel free to interrupt me with questions at any point. So the first of these is already released. You can get it if you want it. It's the combination of the splitter and the mirror VFDs. The objective here is to allow HDF5 to mirror an HDF5 file on a remote system as it is being written on a local system. You can see the block diagram here. The basic idea is first to create a splitter VFD, which takes all I/O calls and sends them down to the VFD on the local system so that we can read and write the HDF5 file as normal. But we also have a write-only channel coming out of the splitter VFD, which, when hooked up to the mirror VFD, allows us to relay these writes across to a remote system where they're written on the file system on that remote system. The implementation here is sockets-based. It is most emphatically not optimized for performance. You're going to be seeing a pretty severe slowdown. On the other hand, this is a feature we've had some requests for, and you should view this as sort of an initial implementation, and we'll see how much support it gets. So, absent questions for that, I'll go on. Second one is the Onion VFD. And here the objective was to give us some very coarse version control and provenance management. By coarse, I mean we're only allowing you to back up to a version of the file as of the previous file close, or for that matter, any previous file close. Right now, we're annotating each version with date, ID of user, and an optional comment. Obviously, if there are requests for additional documentation, we can add that. So this was implemented at the VFD layer, the idea being to keep it pretty much completely transparent from the library proper. The basic idea was to break the HDF5 file into logical pages, and then the first time a page is modified after file open, we do a copy on write and apply further changes to the copy. And then for each version of the file, we have an index mapping logical pages to the appropriate physical pages. We do have a minimal implementation right now. I think there's some minor issues which are still being chased. but the hope is to have a demo which will probably be shown at the next hug. As to when it makes it into a regular release, that's unknown at this time. I also have a little example of what might be happening with this. The idea is that version 0 would be generated as usual, and then you'd shift over to the Onion VFD to keep track of any modifications to the original version. You can see here some examples of modifying and adding pages, and in the table over here you can see how this would be mapped from logical to physical page. I should add there's several possible ways of implementing this. We could keep the modified pages in the same file as the original. We could have one auxiliary file, or we could have a different file per version. For right now, we have kept the second option. Also, while we're not implementing it right now, the design does permit us to have forks in the file. That didn't seem necessary in our initial implementation. And again, whether we do that is going to depend on what sort of feedback we get and what kind of requests we get. So, going on to the SWMR redesign and reimplementation. For those of you who are not familiar, SWMR stands for Single Writer Multiple Reader. The idea being to allow one or more reader processes to look at data as it is being written to an HDF5 file. A number of applications for this. The one that we were interested in initially for this was collecting experimental data and steering the experiment as you go along, but there are other applications as well. Now we have an existing implementation of SWMR. It has a number of limitations, and our objective here was to relieve some of those limitations, and from my perspective as principal architect, to improve modularity and maintainability. So in addition to that, the hope was that we could implement full SWMR, by which I mean allowing the use of all HDF5 API calls in SWMR mode, set up some sort of real-time guarantees, which in this context means to be able to tell the user that, assuming the file system can keep up, we will have a maximum time from write to visibility for the readers. We'd like to be able to support non-POSIX file systems, specifically NFS to begin with, although there are other options as time permits. And finally, to support SWMR in parallel. Obviously, these last four, none of them are supported by the existing implementation. We've done pretty well with the new implementation. We certainly have 1 and 2. Design work for non-POSIX file systems is done. We're starting on implementation. Parallel probably won't happen until sometime next year. So, quick overview of how we're doing it. The basic idea is to use a snapshot-based design. So, if bandwidth weren't an issue, you can imagine just taking a snapshot of the HDF5 metadata once every tick. And for our purposes, tick is typically several hundred milliseconds. It is user configurable. Right now, I think the minimum tick length is 100 milliseconds, and maximum would be out in the several second range. And then write these snapshots to an auxiliary metadata file. The readers can then use a specialized VFD to intercept metadata read requests and satisfy them from the snapshot in the metadata file. And then, of course, we have to check for a new snapshot once per tick. To minimize the size of the metadata file, we allow the snapshots to expire after max lag ticks. Max lag is typically about 7. And then I hope you can see that if the file system can keep up, writes become visible to the readers within 3 ticks. Now this is of course oversimplified. We want to minimize the amount that we write to the metadata file, so there are a number of tricks going on there. If you want to see the details, please take a look at the RFC. So I think the next slide is sort of an oversimplified block diagram, which is just repeating what I just said. Are there any questions at this point? Is the concept of the operation clear? Well, I'll take that as meaning it's either crystal clear or clear as mud. So let's go on to a discussion of the design implications of this. So the big advantage of the snapshot design is it makes VFD almost completely transparent to the HDF5 library. Only the metadata cache, page buffer, and the VFD layer need to know about SWMR. Thus, most elements of HDF5 just work, reading, giving us almost full SWMR. There are a few exceptions. Variable length raw data, due to the design or the way that it is implemented, will not work at present. To get this to work, we're going to have to re-implement our support for variable length raw data. Until then, you should just avoid it. If you have a very long-running API call that takes more than max lag ticks to execute, it's going to fail, as the reader will notice that more than max lag ticks have passed. It then knows that it potentially has a corrupted view of metadata, and it'll be very unhappy. I think right now we're throwing an assertion failure. We're in the process of replacing that with a more useful error message. Obviously, the solution here is to avoid the long-running API calls, or if you have to have them, break them up a bit. Older versions of the file format can create arbitrarily large pieces of metadata, causing very large metadata files. Thus, there's a strong recommendation to only use the latest file format with VFD SWMR. The truth of the matter is the earlier versions work just fine, as long as your file is fairly simple. But I think officially we're only going to support the latest file format. And then, of course, coming back to my hobby horse as architect, the upper levels of the library can just ignore SWMR, which reduces maintenance costs and avoids SWMR overhead for non-SWMR applications. So a few other implications. First, the snapshots don't require POSIX semantics. Thus, VFD SWMR for NFS is possible. What we do in this case is, instead of maintaining the metadata file, we, in essence, generate updater files, which can be read by an auxiliary process and applied to a local copy of the metadata file on a local POSIX file system. We can do VFD SWMR on a remote system. This is possible, pretty straightforward. On the HDF5 file proper, we just use the mirror VFD, which I discussed before. We also have to do that for the metadata file, assuming the writer is maintaining the metadata file directly. That we need to go and implement. Right now, the necessary glue code isn't there, but I expect we'll be dealing with it fairly soon. Alternatively, of course, once the updater files for NFS are available, that information can be transmitted by that mechanism as well. One of the interesting implications of the snapshot-based design is that it also allows us as a fringe benefit to support course metadata journaling for crash recovery. Once we have that, and once we make a couple minor tweaks to our space allocation so that data once, or file space once allocated for either metadata or raw data does not get freed and then reallocated for the opposite use. Once we have that in, we can then just keep the sequence of updater files and then apply them in order to the HDF5 file, and then create or modify the HDF5 file so that the metadata is consistent up to the last snapshot. So that's something that we'll be working on once we get the NFS support in. And of course, coming back to my hobby horse, new features should just work with little or no additional development effort. So a bit on current status. Alpha release out. This was written a little while ago, so the new alpha release, I believe, is out right now. We're only doing Unix, Linux, and Mac OS. Windows should be coming. Only serial POSIX support for now. And right now we're hard-coded to flush raw data rather at the end of each tick. We actually have made this configurable on the version. We've done a fair bit of testing with that. Really works rather nicely. The only gotcha on that one is that if you're doing work with region references and such, you really want to turn off flush of raw data at the end of tick, as that will tend to cause your region references to potentially point to things that don't exist at present. So we've done a little bit of performance testing, and I'll show you what's going on with that shortly. Bottom line is you'll get your best performance with small numbers of data sets with at most one extensible dimension. Group creation overhead is minimal. File close can be slow, and I should explain briefly what's going on with that. Because of the tricks that we play to avoid unnecessarily large metadata writes, under certain circumstances, we allow metadata writes to be satisfied from the HDF5 file proper, not from the metadata file. That in turn means that we have to be careful about posting metadata writes to the HDF5 file so that the reader doesn't get messages from the future. As a result, the close can take up to max lag ticks to complete. I haven't seen any particular problems with this, but you should be aware of that. First production version by the end of this year. I would say we're pretty close to on track for that. Frankly, if there's a delay, it's probably going to be because of me, because I'm going to insist a full personal review of the code and update of the RFC to get all of that in order before it goes out the door. So, some performance results on large data set writes. These are initial results. We're in the process of doing a more complete performance study to see how various tweaks will affect this. Although, as you'll see here, we're frankly good enough right now. In this particular study, we were looking at data sets of n by 1,000 by 1,000 dimension. The idea was we're saving frames from some sort of detector to a data set. We set it up with 1 by 1,000 chunks, and we were cycling through the data sets. On each cycle, we were extending the data set by 1 chunk and adding 1 frame. We're using a 4 kilobyte page size and a 4 megabyte page buffer with raw data flushed at the end of each tick. And if you look down here, we were comparing VFD SWMR writer with just straight HDF5, no particular tweaks either way. Bizarrely, we actually got a bit of a speed up on the with only 10 data sets. I'm going to guess that is due to metadata just sitting in the page buffer and not getting written until close, or written to the HDF5 file until close. When we moved it up to 100 data sets, as you can see, we got a small slowdown, about 9%. On the other hand, if you have lots and lots of tiny data sets, things get much worse. In this case, we were looking at 1 by 16 by 16 chunks. Same arrangement on each cycle. We're extending each data set by 1 chunk and writing 1 16 by 16 frame. Pretty much everything else was the same. Again, flushing raw data at the end of each tick. Now, if you look at this table, when we get out to 10,000 data sets, you can see we were having a pretty large slowdown relative to the straight HDF5. Whereas I said, we're working on looking at alternate configurations to see if we can improve that. My guess is we'll get a fair bit, but that gives you an upper bound on what sort of slowdowns you should see. Finally, before going on, I should mention that from an HDF5 perspective, this particular design of the data sets was just silly. We were using very tiny chunks. Part of the objective here was to work VFD SWMR as hard as possible and putting it in a mode where it was generating huge amounts of data sets because of huge amounts of metadata, because of course on each cycle, all of the indices are being extended by this 1 frame. And of course, at the end of each tick, all of these modifications to the indices have to be written to the metadata file. So, as the saying goes, you probably don't want to do this. You would want to use a very different data set setup. Finally, we took a quick look at group creation, again, some initial results. And, well, as you can see, for any sane and frankly rather insane numbers of groups, the slowdown with respect to straight HDF5 is really negligible. So I think that covers this particular presentation. Any comments or questions? Well, Lori, at this point, do we
Actually,
want to
so
end this or what happens next?
I do have a question, sort of. Elena wanted me to ask you to talk
Hello?
a little bit about, can you not, John, can you hear me? Can anyone else hear me?
I can hear you.
Are we still there? I'm not receiving any audio back. So Steve, Lori?
Yep, I'm here.
I can hear you.
You're there? No
Yeah.
audio?
No, you can't hear us. Okay, so we're going to end. If there are questions, since I seem to have difficulties receiving audio, they could go into the chat. So Dax, did you have a question?
file locking questions. Okay, let me see something. I can see this headset is going to have to go. All right.
So for everyone else,
File
we
locking
put,
changes be brought back to 110.8. My recollection is those file locking changes were brought into HDF5 for purposes of the initial swimmer. Okay, thank you. Let's see if this will help any. I'm getting no audio here.
Well, we probably need to talk. That might help.
Nothing.
We can hear you.
Concluding works with me.
okay. Thank you, everyone. We will see about scheduling a time to talk more about this question. We've kind of been bouncing about file locking, but for everyone else, thank you so much for joining us. We will post the recording and we'll see you here next week. Thank you.